In this video, we are talking about factoring. So first, what is factoring? Factoring is the process of splitting an expression into the pieces that would multiply together to result in that expression. So you can think of factoring polynomials as undoing the multiplication of polynomials. And what is a GCF? A GCF itself means greatest common factor. Now, a greatest common factor is just the largest value that will divide each term evenly. So a GCF, a greatest common factor, can be a number, it can be a variable with an exponent or without an exponent, or it could be a combination of a number and a variable. So let's look at just a basic example. What is the greatest common factor of 24, 6, and 12? Well, what is the largest number that will divide each of those evenly? Well, if you're looking at these, you think, oh, well, each one is divisible by 2. 24 divided by 2, 6 divided by 2, and 12 divided by 2 all result in whole numbers. But 2 is not the largest number that will divide them. So it's not the GCF, even though 2 is a factor. So continuing to think about these, what is a bigger number that will divide each of them evenly? Well, you can look at 6 itself. 6 divided by 6 is 1, 24 divided by 6 is 4, and 12 divided by 6 is 2. So 6 is the GCF because it is the largest number that divides them all evenly. Now, if we apply this same concept to a polynomial, it's the same idea. What is the GCF of this polynomial? 24x squared plus 6x plus 12. So instead of having just the individual numbers listed, we have a polynomial here. So we're still looking at the numbers in this polynomial, 24, 6, and 12. So the greatest common factor of this is going to be 6 again, because we can divide each of these terms by 6 evenly. So 24x squared divided by 6 would give us 4x squared. 6x divided by 6 would give us 1x. And 12 divided by 6 would give us 2. So, since all of those result in whole numbers, 6, again, is the GCF. So that's just the basic concept of how to find the GCF. Now we're going to do some examples. Now in these examples, I have a flow map for you so that you can follow along in this process. The first step of factoring by GCF is to find what the GCF is to begin with. So step 1 is always to find the GCF. So the GCF of this example is what? Well, what's the biggest number that can divide each of these evenly? Okay, well, 3 divided by 3 is 1. 6 divided by 3 is 2. And 12 divided by 3 is 4. So those all give us whole numbers. But notice that I cannot divide all of these by 6, because if I divide 6 by 6, that's 1. 12 divided by 6 is 2, but 3 divided by 6 is 1/2, not a whole number. So our GCF is 3. That's the largest number that can divide all of those evenly. Our second step is to divide each of those terms, which we already kind of did that. So if I divide each of these terms, that means I had 3x squared plus 6x plus 12. Our second step is to actually divide by the GCF. So I'm dividing each term divided by 3. Now when we do that, we are going to simplify that. And what we simplify is going to go into parentheses. So I'm going to write a set of parentheses and do my simplification. So 3 divided by 3 is equal to 1, so that's 1x squared. 6 divided by 3 is 2x, because that was 6x divided by 3. And then 12 divided by 3 is positive 4. So I'm almost done with my factoring. I've already simplified by factoring out the GCF. Now I have to write the GCF in front of those parentheses. So what we've done is we've taken this expression and we have split it up to be 3 times a polynomial that would result in this if we multiplied them back together. So notice if I multiplied these back together, so if I were to redo that multiplication, I would do 3 times x squared, which would give me 3x squared. 3 times 2x, which would be 6x. And 3 times 4 would give me 12. So notice this is the same as what we started with. That's how you'll know that your factoring was done correctly. So our final factored answer is 3 times x squared plus 2x plus 4. That is our completed factoring by GCF. Okay, let's look at another one. First, we want to find the GCF. So what's the largest number that will divide all of these terms evenly? Well, looking at these, I can see that all of them are divisible by 7. Now, since that first term, our a value here, since this is a quadratic, is a negative, if I can divide by that negative, I would want to do that. Okay, so we want to divide by -7 because this leading number is a negative. So our step 2 is to divide by the GCF. So everything gets divided by -7. Okay, now our process is just simplifying and place your GCF in front of the parentheses. So I'm going to have a set of parentheses and my GCF is going to go in front. Okay, now I'm simplifying. -7 divided by -7 is 1x squared. Now 49 divided by -7 is going to be a -7x. And then -14 divided by -7 is going to be +2. And that is our final answer for factoring by GCF. Now we could check this by seeing when I multiply this back out, -7 times x squared would be -7x squared. -7 times -7x would be a +49x. And then negative 7 times 2 would be a negative 14. If that matches what I had to begin with, then I'm good to go. And it does, so we are correct in our factoring. So really your last step, you could consider it as checking to see that it multiplies to be what you started with. Okay, just a couple more. Now, if you don't have a full trinomial, so let's say you only have 2 terms, you can still factor by GCF. So we're still looking to see what's the biggest thing that will divide each of those terms evenly. Well, in this case, we have a 1x squared plus 7x. Now, 1 and 7, what divides both of them evenly? Well, the only thing that will divide them evenly is 1. So since we can't really take out a GCF because there's no need in factoring out a 1, that doesn't change anything. We can also look for the variables that they have in common. So since this has an x to the second power and a 7x, what we can say is that the greatest common factor is actually just an x because they both have an x. So the GCF is x. Now we're going to still divide by the GCF. So we had x squared plus 7x, and we're going to divide both of them by x. Now when you're dividing variables, essentially what happens is you're subtracting the exponents. So basically we're taking an x away from each of those terms. So what will happen here is I'm still going to write my parentheses. The GCF is going to go in front, and then we simplify. Well, if I have x squared, so I have x times x, and I take one of those away, or I divide one of them or factor it out, I'm going to be left with one less than what I had. So if I take out an x from here, if I take one of those x's away, then I'm only left with one x, an x to the first power. Then when I divide 7x divided by x, well, x divided by x is 1. So that x goes away. And I'm left with just x plus 7. Now we can always double check this. So when we multiply this back together, do we still get what we started with? Well, if I do x times x, that is x squared. If I multiply x times 7, that is 7x. And that's what we started with. Okay, now this time we have a trinomial, but notice that it's not a quadratic because the highest exponent is 3, not 2. So we're still going to look for a number that divides all of them evenly. Well, our numbers here, our coefficients, are 3, 2, and 1. Nothing divides those evenly except for 1. So we don't want to factor out a GCF of 1. That doesn't do us any good. So now we're going to look for variables. Do they all have a variable in common? Well, this one has an x to the third, this one has x to the second, and this one is just an x. So since they all have an x, we can divide by x as our GCF. So our GCF here is x again. So we're going to divide all of them by x. So we're dividing by x on all 3 of those terms. Okay, now we're going to split our parentheses, and our GCF is going to go in front. Now we simplify. So if I had x to the third, and I'm taking 1 away, that would leave me with x to the second power. X squared divided by x, I'm taking one of those exponents away, so that would be plus whoops, I forgot my 3 in the front there. That would be 2x. And then x divided by x is 1, so plus 1. Okay, so this is our final answer. But let's make sure that when we multiply, we get back what we started with. So 3x squared times x. So that would give us 3x to the third power. Then x times 2x would give us 2x to the second power. And x times 1 would give us 1x. So that checks out. And finally, what happens if they do have a GCF that's a number, but they also all have an x with them? Well, then we can factor out both. Right, so in this case, we have 6, we have -3, and we have +3. Now, since our leading number is a +6, we don't need to divide by a negative. So what we want to say is, what's the biggest thing that goes into 6, -3, and 3? That would be 3. Okay, so we know that part of our GCF is going to be 3. But these all also have an x. We have an x to the third, x squared, and an x. So we can also take out an x with that. So what we're going to do is divide everything by 3x. So we're going to divide by 3x for all of these. Then when we simplify, we're still going to put our GCF in front of the parentheses and simplify inside the parentheses. So 6 divided by 3 is 2. And x to the third divided by x, we take one of those exponents away. We subtract those. So that would be x to the second power. Then we have -3 divided by 3 is -1. And x squared divided by x, we're going to take away one of those x squared exponents. So that would be x to the first power. And finally, 3 divided by 3 is 1. And x divided by x is 1 as well. So our final answer here is 3x times 2x squared minus 1x plus 1. Okay, let's multiply this back out to make sure we get what we started with. So 3x times 2x squared. 3 times 2 is 6. X times x squared is x to the third power. Then 3x times -1x. 3 times -1 is -3. X times x is x squared. And then 3x times 1 is just 3x. And that is what we started with. So this is how you can factor with GCF. Your GCF, remember, it can be a number, it can be a variable, or it can be a number with a variable.